Good afternoon. We are the Covenant Christian Academy Advanced Classic Division team. The first thing we want to talk to you about today is creating an environment for long-term success within our school. For the first 3 years of our solar car program, we drove all the way from Colleyville out to Mineral Wells to a shop generously loaned to us by Mr. Mark Rose. This 2.5 hours of travel time made it very difficult for students to be involved in our solar car program. But in November of 2019, we moved into a new shop just 3 miles from the school, which made it easier for students to participate. Initially, for 2020, we were able to attract 13 new students for a total program size of 16 with our new shop just 3 miles away. But after 5 months of COVID quarantine, we lost several students and now have a total of 9 new students for a grand total of 12 people in our program. Historically, CCA Solar Car Program has been a club activity. It was solely parent organized and sponsored, and students received no elective school credit. But starting with 2021, we now have a dedicated teacher that's been assigned to us who will begin to lead the team starting in 2022, and an elective credit has been created for us. Our team is now on firmer footing for long-term success, beyond the initial founding parents and students who started our team. Here we are moving into our new shop. Here we are building all of our shelving and moving in all the equipment loaned to us by Mr. Mark Rose. As far as team organization goes, during the design and construction phases, all CCA Solar Car students are a part of a larger team, where everyone is involved in all aspects of the Advanced Classic and Advanced Division cars. Unlike some larger teams, we do not have separate electrical, mechanical, or telemetry teams, so that all students can gain broader experience in all aspects of the cars. During the race event, though, the 12th grade students will be organized into a senior varsity team with our Advanced Division car, while 11th and under will be organized into a junior varsity team with our Advanced Classic Division car. As far as planning goes for our Advanced Classic Division car, our old car was version 3.0 of our original car we made, and it was highly optimized. But it never placed above 3rd place, because as we got better, so did our competition. So, our objectives for 2021 were to build a new, lighter car to lower power consumption, and to build a new 9 square meter, 20% efficient solar array.
So this supports our engineering decisions for our car. So our first goal was to build an entirely new car that weighs at or under 700 pounds. We decided to build a slightly stronger version of the aluminum monocoque car that we raced in 2019 and the Advanced Division. To handle the extra weight of the lead-acid batteries that we're using, we also used thicker aluminum in key areas as well as 2 rear tires. We believe that this new car will reduce overall power consumption by 20% relative to the car we used in 2019.
Our goal number 2 was to build a 20% efficient array that fit in the 9 square meter solar array. Given that the updated rules allowed 20% efficient modules and our old module was 18.3% efficient, we felt an upgrade was needed. We purchased 6 new modules at 300 watts each from Shine Solar, and those fit exactly within the 5 by 1.8 meter size limitation. This should provide a 9% increase in production relative to our old 600 watt array that we used in 2019.
So here are pictures of us working with our mechanical engineering advisor, Mr. Mark Rose, as we designed work for the new aluminum monocoque chassis that we used to support the extra weight that we added to the car. And in these pictures, we're using a program to design mechanical drawings for the car.
Here's the mechanical drawing for our car, and I'd like to point out 3 things about it. Firstly, as we mentioned earlier, the body and frame of the car are an aluminum monocoque construction. Secondly, the side crush zones were filled with Hexel honeycomb to distribute impact force and direct it away from the driver. And finally, the suspension roll bar and upper crash zone were created from steel.
For our high voltage schematic, we have our 6 300 watt modules that make a 1.8 kilowatt array. We have our charge controller by Outback Power. We have our 4 sun extender batteries that approximately make a 5 kilowatt hour battery bank. And we have our 3 kW brushless motor by Golden Motor. For our low voltage schematic, we did not change anything on it because nothing else changed, so we didn't need to. These are the highlights from our construction of the new monocoque chassis. So as you can see, we first just started off with just a sheet of aluminum, and then we added our bulkheads and our roll bar, and we worked on the instrument panel, which we made removable, so you can take it off. And we also made the high voltage enclosure. And this is the near to final chassis with the rear suspension included.
For our solar array frame, we were able to use 2-inch by 1-inch rectangular tubing for vertical and perimeter rigidity. For horizontal rigidity, we also used 3/4-inch aluminum pipes brazed on for horizontal rigidity. We used 2 construction methods. We used riveting and aluminum brazing. We also constructed a solar array tilt mechanism that we constructed and attached to the frame. This allowed us to charge more efficiently during the downtime of the races. We also constructed and soldered our solar array panel together, which came out correct as we imagined.
For fundraising, before the pandemic, our team was able to raise $20,000 in outside fundraising, but ever since, it's been difficult to do it. For vehicle testing, because of all the delays during the pandemic, our team has not been able to complete the construction of the new Advanced Classic Division car, but we do hope to test it out 2 to 3 weeks before the race event. Thank you.